Hello everyone, and happy 4th of July. This episode is going to be focused on creating injection molded covers and the different rules, rules of thumb and tips for injection molded products. So what I'm going to do today is create a housing, like a face covering for this display, and it's going to have screw bosses, and it's going to have ribs, and it's going to have an opening to make sure that the display can show through. And so it's going to be an injection molded part with a certain wall thickness, etc. And there's some really cool rules and techniques because NX really allows you an amazing power to do so. So to start with, I want to make a housing. And so I'm going to start with an assembly where I bring the housing in. But as you can see, I've got this model of this display, and the display has an active area. And what I've done thus far is I've created the display and I've created a sketch that represents the active area. I've used that sketch to divide the face so that I know the exact dimensions of the active area, and these dimensions may change. And so the very first thing I want to do is make sure that when I bring this into an assembly, I'm bookkeeping, if you will, that active area. So what I'm going to do first is go to Assemblies and go to the Interpart Links More and do a Product Interface. Product Interface is fantastic. And I'm going to do what's called a composite face. And when I select this face, that's going to be the composite face, the interface that I'm making. Here it is, and I'm now going to do interface properties and rename it as the active area. The active area. There you go. Say OK, and say OK. Great. So now the very next thing to do is to create a new assembly and create a face cover, or let's call it the front cover with the screw bosses in an assembly file. If I click on New Parent Assembly, it will give me an assembly file without a coordinate system. And I kind of like to have a coordinate system, so I'm going to say File New, and I'm literally going to use my modeling template as to create an assembly. I'm going to put an underscore before the name, and I'm going to call this the assembly with the display and the front cover. I know it's a very awkward name, but this is just an example, right? So now I've got this blank part file, and I'm going to bring in the display. So I'm going to say Add Component, and I'm going to add the display. So here it goes. I'm going to say OK, and I'm going to fix it in its location. And what I was talking about before is when I bring this display into the assembly, there's a coordinate system in the assembly part file. So if I take the display away, see that? There's still left this coordinate. And you know, I think I've changed my mind a little bit. I think I would like the display, or the active area of the display, to be centered about the central coordinate system. And so I'm going to go to the display. I'm going to remove the fix constraint, and I'm going to show you that I'm going to now constrain this so that the active area of the display is right in the center of my assembly. And in order to do that, I'm going to do a touch command. I'm going to do an align command between the XY plane there and the face of the display. So as you can see, that's what that does. And now I'm going to use the center command, center, and I'm going to center 1 to 2. 1 to 2. What does that mean? The 1 is the YZ plane of the datum CSys, and the 2 will be one edge of the active area and the other edge of the active area. So that forces the display to be right in the center. And you know, when I did that, it didn't really show that it moved. And so I'm going to suppress it, and I'm going to move this thing just so you can see what it actually did. I'm going to move it so it's catawampus like that. And then I'm going to bring back the center display, and look, see, so it's centered. And I'm going to do another center, a 1 to 2. The center command has 3 varieties: 2 to 1, 1 to 2, and 2 to 2. I'm not really sure why you need a 2 to 1 and a 1 to 2, but I'll go for it. So this one's going to be a 1 to 2 again, and I'm going to say the 1 is the XZ plane of the central coordinate system. And then the 2 is the top edge of the display and the bottom edge of the display. And you can see that it went in there quite nicely. Good. So now, as you can see, I've got the assembly that I made. I've got the display. I'm looking good. I don't like to see all the stuff that's associated with it. So I'm going to say Control W and get rid of the planes and the coordinate systems and the assembly constraints and the sketches and the curves. And so now you can see that I have my my display. I'm just going to pause for a second. Okay, I'm back. I had to answer that call. My 94-year-old mom calls, and when she calls, I answer right away, as you can imagine. So, what I've done thus far is I've put my display into an assembly, and I've centered it using the center command, 1 to 2, and I've also made a product interface for the actual active area of the display. So the very next thing I'm going to do is put in a brand new component. I'm going to say new component, and this is going to be called front cover. Front cover. And say OK. Front cover. And the very first thing I'm going to do is I'm going to fix that in Sage. Incidentally, when you do menu preferences assembly and you have components, you want to make sure that this new component is set up to select from file new. Otherwise, when you put in that file name, it'll just give you model 1 or model 2. And some people have that set up in that, in my view, disadvantageous pages way. Little thing. Okay, next, we go to the front cover, and I'm just going to open it up in the window. And what I love about the product interface is I can now grab an interface from the display just by saying Home, More, Wave Interface Linker, Geometry Linker, Home, More, Wave Interface Linker. I click on the display and I get the active area. So then the active area comes in the exact right position, and I can then take that active area and start creating components around it. So that is a beautiful and incredibly powerful technique. Now the active area, of course, comes in a location that is commensurate with the way it's created in the actual part. So that's why it's hovering above like this. But that's okay because I can use the dimensions of the active area when I create my front cover. So now that I have that in the actual front cover, I'm going to open that in a window, and I'm going to make my front cover in a way that makes sense based on this active area as my display. So what I want to do is have the opening of my front cover to be the exact same size as the active area of this piece of geometry. And what I want to do is make sure that my active area is centered about the coordinate system. I want 0, 0, 0 to match up with everything else. And I also want to set a nominal wall thickness. So I'm going to say Control E, and I'm going to create a variable called wall, THK, and the wall thickness is going to start with 2.5 millimeters. And 2.5 millimeters comes just from my own little head, my experience. 2.5 millimeters has always been a pretty good wall thickness for a lot of the products that I've designed in the past. I'm also going to set a rib thickness. The ribs in general are 50 to 60% of the wall thickness. That's just the rule of thumb. So I'm going to do this wall, THK times 0.6, and that's really good. I'm also going to use some self-tapping screws, some M3 self-tapping screws. And in general, the hole, if I'm going to use ABS, the hole that I'm going to put in my screw boss is going to be 85% of the diameter of the screw boss. So I'm going to say screw boss, or I'm going to say self-tapping screw, or I'll say screw, equals 3. So I'm going to use M3 self-tapping screws. And so therefore, boss hole is going to be the screw times 0.85. So this gives me the ability to change from M3 screw to M4 screw, or whatever screw it is. The hole will change automatically. So that's very nice. And then the screw boss base, the diameter of the screw base, will be at least 2 to 3D. So I'm going to say boss base. Boss base is going to be, let's say, 2.5 times the screw diameter. Just like that. So now I've got all of these things set into place, and that makes it really, really easy for me to design my my nominal wall thickness, my rib thickness. I'm going to say draft. My draft, I'm going to say boss draft. That's an angle, and so I've got to change the dimensionality to angle, and that's going to be 0.5. 0.5 is okay for the draft of a boss, because the boss is generally shiny, and so it's when you pop it out of the mold, it doesn't resist at all. But if you have a textured surface, you could have up to a 2, 3, 4 degree draft, and so I'm going to set that now. So the boss draft is 0.5, and I'm going to say the wall draft, I'm going to call it 3 degrees. And that, again, is an angle. So I've got to change the dimensionality. So it says angle. I'm going to set it at 3 degrees. And now I'm really good to go. I've put a lot of thinking into these numbers. And the great thing about NX is it's so easy to apply these numbers to what I'm doing. So now all I've got to do is create the actual cover. So I'm going to sketch, and I'm going to sketch on the XY plane, because the XY plane to me is special in that when I do this kind of modeling and I have 0, 0, 0 right in the center of the XY plane, everything updates and everything comes together so very well. So I'm going to start a little rectangle, a center rectangle. With the center rectangle, it automatically creates the constraints. You notice I'm using constraints, not relations. These constraints are perpetual, and I love that. And so I'm going to do an equal length between edge of display and the edge of the hole. I'm also going to do an equal length between edge of display and edge of hole. Cool. And so now I don't need to see the actual face that I stole, if you will. That. Okay, so that's going to be the opening. And then I'm going to give you another rectangle. This is not going to be a centered rectangle. This is going to be a rectangle that looks like this. I'm going to center it in the X direction, the midpoint. So there's that and that. But the other dimensions I'm going to do with a actual dimension. So I'm using 0.8 inches there, and I'm going to make it deeper here by 1.6, and I'm going to put an offset here of 1.25. So that is the design, if you will, of my very simple housing. I'm going to just say finish. I'm creating a sketch, obviously. And what I'm going to do next is I'm going to extrude the outside of this, the outside shape. Now, the extrusion is going to be THK, the wall thickness. So I called it wall THK. That's the direction in the Z, in the up direction, if you will. And then the distance downward is -1. That's nice. And I'm going to just say OK on that. And now I'm going to draft this whole thing. Well, I could just draft it with the extrusion. So I'm going to draft from the actual section, not the limit. So you can see that it's holding pristine this sketch that I made. And that sketch is going to be the draft angle. This is the draft of the part. What did I call it? Let's just go into here, formula, and I called it the wall draft. There it goes, the wall draft. That's what I called it. Type that in. Wall draft. Make sure it's going the way that I want. If I look at it from a top view, if you will, you can see that it's going the right way. Say OK. That's nice. Then I'm going to blend the outside with a G2 curvature continuity blend. And my favorite row value is 0.65. And I'm going to base the blends on a 0.5 radius. So I've got that. And I've got this. I've got this. And say OK. Very nice, very nice. I'm also going to do another aesthetic, not an aesthetic face blend, but a very simple G2 face blend, 0.2, let's say, or let's go 2 times the wall thickness, wall THK, with a 0.65, let it go all the way around there, and say OK. Unable to apply blend. Let's see what is going on. I think it might be too small. Interesting. Let's try a quarter inch. Let's just do a formula. 0.25. Okay. It's going to cooperate. No, it's too large. Okay, so I'm just going to, just for the sake of moving forward, I would usually wrestle with that a little bit more, but I'm just going to go with a G1 with a 0.125 or 0.25, and go right around that. Yeah, let's go 0.15. That's it, okay. A little cheating there. Okay. I really want to focus on the injection molded stuff, not the blend stuff. So I could really put an aesthetic face blend on here, but that's going to be another video. Next, I want to shell it out. And to shell it out, I'm going to shell with wall thickness. So I put in W, and it shows me that, and I see wall thickness. Great. And then I could make the hole for the opening for the display. I'm going to say 0 on this, 0, and 1 inch, and I'm going to select the curve like this, and I'm going to change the direction, and I'm going to say subtract, of course, but the most important thing I can say is that I want this to be drafted as well, and I'm drafting from the section, and this is what -40 looks like, and I'm going to give this just my own aesthetic feel, -10. Okay, so that's drafted very well. Nice. Okay, now the bosses. So the bosses I'm going to create with all my nice equations, and I'm just going to create the boss with a circle, a couple circles actually, a couple concentric circles. Okay. Now, one of the things I love about NX, I love a lot of things about NX, is if I go to the part navigator and I go to user expressions, it shows me all the expressions that I used. And as you can see, there's the boss hole, the boss base, the 2.5. So I'm going to put a dimension right here and right here. So that's boss hole. Silly me. That 2.5 and those dimensions need to be in millimeters. So I'm just going to exit this for a second. I'm going to go to Control E. Okay. Control E. And I'm going to say that boss base is 2.5 mm. I started in an inch part file, that's my problem. The boss draft is 0.5, but the screw boss hole is the screw times 0.85, that's good, and the screw is actually 3 mm. Okay? And the wall draft is 3 because that's in inches. So I think I've adjusted everything. Wall thickness, yeah. Wall THK, yeah, okay. Everything else is right. I'm going to apply there, say OK. And as you can see, the sketch is already updated. So there's a boss hole, and we also have the boss diameter, which we have as boss base. Right here, we have boss base. That's good. And somehow I messed it up because what we have to do is make sure that the thickness of the rib, the wall of the rib, is only 65% of the nominal wall thickness. So what I'm going to do is I'm going to delete this. I don't know why this is so wrong. And I'm just going to do one more pause. Okay, I'm back. So let's see. It feels like the boss base is too wide to give me a thickness here that will be 60% of the wall thickness. So I could look at that later. I could just adjust it later. So for now, it will be coded to the boss base. I'll type in boss base. Okay. And that's what it's going to look like. Okay, great. So now I need to take that sketch and extrude it. I'm going to extrude it with the taper. I'm going to extrude both of these entities. I'm going to extrude them 3 times the boss, 3 times the boss base. So I'm going to say 3 times boss base, and that will be unite, if you will, and it will also be drafted from the starting section with a draft of, we have boss draft. And I don't have to remember that because I could see it right up here. That's 0.5 degrees. So that's nice. I'm going to unite that. But then I'm also going to do a little thing here. I'm going to make sure that the floor of this is just a little lower than the wall thickness, like by maybe 10%. So the way to achieve that easily is to do an offset. I'm going to do an offset. And I'm going to click on this little face right here. And I'm going to say minus wall thickness times, let's say 15%, 0.15. And I'm going to say OK there. And I'm going to take a look at that. I'm going to say Control H, and I'm going to rotate this by 90 degrees, and I'm going to click on that little BB and put it right in the center of this hole. Whoops. Come on, you. Put there, and right there at the center point. I lost my rotation. There's that at 90, good. And what you can see, I'm going to say OK here, and what you can see is this is just a little bit lower. So what I'm worried about is the shrink. What I'm worried about is when this thing sets up with the shrink of the material, that there'll be a little indentation there, and it'll tell me, it'll show where the boss is, and that won't look good, especially on the front face. Incidentally, the A surfaces, an A surface, a lot of people think that A surfacing and B surfacing is a mathematical thing. It really isn't. By definition, the A surface is a surface that is going to be cosmetic. It's going to be seen. It's not necessarily a mathematical designation, A and B. Another thing I should do is put blends in here to have the material flow more evenly, more smoothly, and that is going to be a percentage of the overall wall thickness as well. I'm going to call that 0.25 times wall thickness, THK. Does that look pretty good? I'm going to do it here as well. And that makes the material flow better. And then one more thing I'm going to do on this boss before I plop it all over the place is I'm going to put a little indentation right here. So when the self-tapping screw goes into it, it will make the material bulge, and that way I won't get the exact location that I want for the matching boss. And so for that, I'm going to do an extrude. And I'm going to select on the edge as what's going to make the extrude. And I'm going to extrude 0.25 times wall thickness, wall THK. So that's a little downward extrusion, but I'm also going to do a single-sided offset, and that's also going to be 0.25 times wall thickness. There we go. And at the same time, I'm going to draft it So I'm going to say draft from section, and I'm going to start the draft off at 45 degrees. Why? Because I just want to make sure it's going in the right direction. So I'm going to say subtract. So there's what that looks like. But I didn't really want it to be 45 degrees. I only want it to be about 2 degrees. So I'm going to put 2 degrees on here, and then that subtracts a nice little indentation so that when I put my self-tapping screw in there, the bulging and the deformation happens at this edge, not that edge, and that way I get a more accurate surface right here where things have to come together. Cool. So now I've got the screw boss, and now I can go to view and get rid of that. And what I'd like to do now is mirror over these surfaces. I can do it with a mirror feature, but I'm just going to use the synchronous modeling mirror faces because that will be a little bit more instructive, I think. Oh, one of the things I didn't do is place this boss, and arbitrarily I'm just going to locate this boss to be 0.5 inches away from that surface, or maybe 0.6, and 0.6 away from that surface. I should say that edge, 0.6. 0.6. So it's in a definite location. Okay? Face it. Good, good. Okay, the very next thing is to do the other bosses. And in order to do that, I'm going to create a datum plane right on this edge, right in the center of the edge. Cool. And then I'm going to say that there shall be a mirror of these faces. I'm going to do copy face, mirror face, mirror face. Here's mirror face, and I'm going to grab all of those faces like that. And I'm going to mirror them about this center plane, this one first, and say apply. Then I'm going to copy or mirror. So here, let's grab these, and let's grab these, and let's mirror them about this plane. So now I've got 4 identical screw bosses that follow all the cool rules and everything. Good. And now I want to create some ribs. And the ribs are going to be on these edges and such. I also want some ribs to hold in the display. But before I continue, I do want to check out and see what the assembly looks like. So I click on the assembly. I say Control-W to get rid of the sheet bodies. And as you can see, the display looks good. If it wasn't fitting the display area, the viewable area, perfectly, I would see some edges here, but it doesn't. So there's my display, there's my window, fantastic. And in the front cover, I think I will put a little G2 curvature continuity edge blend right there. I don't really like sharp corners in general, but I'm using a nice looking blend right there, and right there. So there you have it. I think I'll even do a little chamfer that goes all around these edges. There we go. So there's my nice little front cover that I've designed. I've used some very nice rules. The last thing I'm going to do is put some ribs in here just to show you how that's done. NX has a very, very nice tool that allows me to do ribs. So I'm going to go to the front cover. I'm going to say open in window, and I'm going to use the rib tool. So you go to more, and you find the rib tool. Here it is, the rib tool. You select a face on which to start sketching your rib structures, and I'm going to put in one line segment that looks like this, and I'm going to center it using a midpoint constraint. So from here to that edge is going to be nice and centered. I'm going to put a dimension from here to there that I could use to control how long this rib is, and I'm going to use the pattern command. I'm going to do a linear pattern, and I'm sorry I can't do a symmetric pattern. So I'll say OK to that, and I'll do it again. Linear object. So those are my ribs for now. I think I'll put a few ribs in here like this. Let's pattern that. Pattern, come here. It is really nice that you could pattern inside of the sketch. Not every modeler allows you to do that. So I'm going to apply that like that. I'm also going to mirror these doodads about this center line here. And that's the extent of the ribs that I'm going to do thus far. I'm going to say finish. And when I do the finish, I'm going to have I'm going to play with the offset, and I'm going to make it 0.5. And as you can see, it's starting to create these ribs. I expected them to stop there. They're going too far, or they're not going far enough. Yeah, I thought they would just make a rib right up here. So it's trying to do the whole thing, and it's failing. So, okay, so I'm going to cancel that. And I'm going to make them the old-fashioned way. I'm going to grab my region, my infer curves, like this. And I'm going to make those ribs. I'm going to give it the 0.5 that I wanted, like that. That's what the ribs look like. But I'm also going to do a two-sided offset. Two-sided offset. And the offset, let's go to user expressions here. The offset is going to be rib wall thickness divided by 2 here. So I'm putting in, it's a two-sided offset. So I'm putting in rib underscore wall where's my, oh no, it's just rib. Sorry about that. Rib divided by 2. And right in here, I want minus rib divided by 2. I'm going to click on this and say make constant. And this is going to be minus rib divided by 2. You know, I probably could have done a symmetric offset. That's even smarter. So that was a little bit of a rookie move. Okay, so that's all set. And then I do want to do a draft from the section. And the draft is going to be, boss draft is good. I didn't have rib draft, but it's the same thing, 0.5. So now I'm going to do none. No Boolean. Why not? I'm not going to Boolean because if I Boolean, then all of this stuff would stick outside. And what I want to do is say that there shall be a unite created, and that's going to be my target. And all of these are going to be the tools. And then I'm going to say define regions, and I'm going to remove that, and that, and that, and that. I know it's a little tedious, but it goes quickly. I love this tool. So there we go. Isn't that nice? And then I also want to give it a little radius so it flows better. But first, I'm going to do a radius here. Now this doesn't have to be G2. This could be a G1. It's not even cosmetic. And I'm going to do that and hope that when I hit the select predicted objects, it does them all, which it does. Thank you, NX. Of course, I didn't want this one. So I'm going to go back. Cancel that. Let's hit that again. Let's say blend. And I'm going to grab this, and I want all those that are identical. And as you can see, they're all highlighting. But I don't want this one highlighted. So I'm going to go to my selection prediction options, and I'm just going to reduce the sensitivity ever so slightly. And it looks like it's not going to let me increase the sensitivity. If I do that, if I do that, it goes away. Do that, it goes away. Okay, well, let's go for it. And say OK. Or say apply. That blend was supposed to be a lot bigger. Let's make it 0.25. Okay. C1. Edge blend. Let's just take it out. Delete that. And let's do, yeah, edge blend. Like that. It is a G1. It's that big. It should not be placed here, but I do like that it's placed everywhere else. And I am going to try one more time to reduce the sensitivity so that the little insides go away. There we go. Say enter. It's driving me crazy. Try it one more time. So, edge blend, C1, it's 0.25. When I select this edge here, I accept the predicted objects, and it does mostly what I want. Hold my finger on the shift key and get rid of the ones I don't want. And say OK. Nice, nice, nice. Next, I want to put little blends at these interfaces. So I'm going to go blend. And we're going to blend feature intersection edges. And this blend is going to be pretty small, 0.05. And I'm going to select that whole feature. Look at that. Isn't that nice? That's perfectly what I wanted. Maybe it's a little big, so I'm going to say 0.025. Okay. 0.025. There we go. So there you have it. That's a lot of different things that have to come together just right. And of course, the beauty of all of this is if I do some analysis and find out that my wall thickness is actually a little too big, I could always go into the wall, THK right here, 2.5 millimeters, and I could make it, let's say, 2 millimeters. And say, okay. And then everything updates. The wall thickness updates commensurately. This is such power. This is so important to me to be able to do this. What I might show you, one more little thing, is if I want to make a nice little lip in here, it's very easy to sketch on path, do single curve, select one little single curve, and then say OK. And then what we're doing is, on that little sketch, we're going to do an intersection with this face. Oh, I'm sorry, it's going to be both of those faces. Apply. And then we'll do another intersect with this face. Apply. And perhaps another intersect with these two faces. Apply. And now, what we have is a really nice way of making a logical lip, if you will. I'm going to select these entities and make them reference entities. Just select on them and go to the reference, like so. And what I'm going to do is make a nice little lip structure. So it's going to be a line, straight line, and a horizontal line. And then we're going to make parallel this datum axis and this line that's going in the same direction as the surface. Then we're going to create a dimension. Oh, I'm going to put a little point here. A little point right there. And that point is going to be point on curve. Point on curve. And that allows me to have a nice measurement. And so what I'm going to do is measure from this line to that point. I'm going to show this again. 2 or more sketch constraints. It didn't like that. Let's do it again. Let's dimension from that point to that point. Okay? And although there's a little bit of an angle to it, I'm going to just say wall THK divided by 2. That's nice. And I think I'll do the same thing in the other direction, from there to there. That point will also be wall THK divided by 2. So that's going to be the perfect lip all the time with the perfect angle. I'm going to put some arbitrary dimensions in here just to lock it in place so that it's never, during any kind of update, it doesn't get too small. There. Good. And finally, I'm going to use the edge of this thing to drive that around as a cutter. In order to do that, you go to Surface, More, Sweep Along Guide. The section string is like this. There. That's the section string. And then the guide curve is tangent curves of just the edge. And that makes a nice solid that we can subtract from the overall housing. And so there's my lip. So cool. So now if I go back into the assembly, like that, I can see that everything is together. What I need to do now is make little artifacts that hold the display in. That's another time. And I also, at another time, will check the draft angles. There's a draft angle check to do, and some other things that are associated with injection molded pieces. So that was a long video, but I think it says a lot of different things. Appreciate your patience. Please like and subscribe if you appreciated what I just showed you. It's very powerful techniques. And ring the little bell and all of that. Tell your friends about this channel. It's all about showing very powerful NX techniques and making it real. Showing how they really, really work in real life. I really appreciate the software. It's excellent software. But even more, I appreciate all of you out there who have been giving me great comments and listening to these things. It's nice to share what I know. Thank you very much. Again, my name is Steve Samuel from Design Visionaries, and of course on this channel, there's many more videos that are like this one. Thank you.